Check if it works.
Okay, hello everyone. Welcome to the meeting of the 6LO working group. Please make sure that you are in the right room. My name is Carlos Gomez, the other chair is Shweta Bandari, and as you can see, we are both remote today. However, we are happy to say that we have actually now sitting on the table Pascal as our in-person delegate, and also in person sitting next to him is our responsible AD, Eric Klein. So we need a couple of minute takers. Is there anyone who would like to volunteer? So remember that it's not necessary to write everything that's being said. We just need the main action points, the main decisions to be recorded. Okay, so if no one volunteers, well, we'll try to handle that by ourselves. Anyway, recall that we are using, as usual, HeadsDoc for taking minutes. So everyone feel free to join this collaborative process of taking minutes by means of HeadsDoc. So now the link to the minutes is also on the chat. So, as in the last few IETF meetings since the COVID outbreak, there are also some meeting tips, also for this session, this meeting. For in-person participants, remember that you need to join the Miteco session, for example, from the on-site tool that you can find from the data tracker agenda. Remember that there's a single unified queue, which is handled from Miteco. Therefore, you need to use Miteco to join the queue. Also, blue sheets are automatically generated from Miteco. So please do join the session if you are in the room. And then for remote participants, just keep your audio and video off unless you are presenting. This is the notewell. This is a reminder of IETF policies which are in effect on a number of topics which are important, such as patents, code of conduct, and so on. So please make sure that you have read it. And this is the agenda proposed for today. So the first presentation is the usual chair's introduction, which is currently in progress. This will be followed by a presentation given, in this case, by myself on the draft entitled Transmission of Sheet Compress Packets over 15.4 Networks. This will be followed by a set of two presentations given by Luigi Annone, the first being the base PASA draft. This is path-aware semantic addressing for LLMs. And the second one, it's a new individual draft, which is related with the first one. However, it's more generic. It's entitled Generic Address Assignment Option for 6LoWPAN ND. This will be followed by a set of two presentations given by Pascal. The first is on the recently adopted draft on IPv6 ND prefix registration. And the second one is rather a heads up on a six-man working group document which Pascal is leading, which is entitled Architecture and Framework for IPv6 over Non-Broadcast Access. This document includes some sections which focus on the optimizations and extensions for neighbor discovery that have been developed by the 6LoWPAN and 6Lo working groups. And finally, the last presentation is on another new internet draft, which is entitled Transmission of IPv6 Packets over Short-Range Optical Wireless Communication, and will be given by Yongwan. So as you can see, in total, there's 80 minutes of allocated time in the agenda. So this is a quite packed agenda, and we'll need to kindly ask the presenters and participants to try to stick to the allocated times, hopefully with some margin for discussion. And other than that, is there maybe any comment on the agenda? Okay, so if there's no comments, then we're going to present the usual status report of the working group documents. First of all, since the last IETF, we have a new RFC, which is the IPv6 over NFC document. This is RFC 9428. Actually, well, congratulations to the authors and many thanks to everyone who has been involved in the process, who has contributed with reviews, comments, and so on. This has been quite a journey, and we are happy with the outcome. So again, thanks to everyone for the effort. Then the second document is the 6LO use cases draft, which is currently in the RFC editor queue in state RFC editor. And also publication has been requested for the draft on IPv6ND multicast address listener subscription. Perhaps we could take the opportunity to ask our AD, Eric, which would be the plan for the next steps for this document?
I think I already changed that status to AD eval. So the next thing for me to do is the AD evaluation, and then send any comments back. After any necessary revisions, it goes to IETF last call. So sometime in the next couple of weeks, although I think we have 400 pages on the next telechat, maybe at the end of August, if that's okay.
Okay, thank you very much. And then the three other working group documents are at earlier stages. The first one is the path-aware semantic addressing for LLMs, which is at version 02 and will be presented later today. The other one is the transmission of SHIC compressed packets over IEEE 802.15.4 networks, which is also at version 02 and will also be presented. And the last one, which was adopted just a couple of days ago, is the IPv6 and the prefix registration, which will also be presented later today. So any comments or questions? If none, then we can proceed to the second presentation. So in this case, I will be giving the presentation. So hello again. I'm going to present the last update of the draft entitled Transmission of SHIC compressed packets over IEEE 802.15.4 networks. My co-author is Ana Minaburo. And just a quick reminder on what we are doing in the document. On the left side of the screen, you can see the traditional 6LoWPAN based protocol stack over 15.4. Then in this document, the main goal is to offer an alternative to 6LoWPAN header compression, which would be using SHIC header compression. Recall that SHIC is the main product of the LP1 working group, which exploits a priori knowledge of header field values of the packets that will be transmitted in order to potentially obtain very good compression performance. Also, in the document, we are specifying what we call the transition protocol stack, which still allows to use 6LoWPAN header compression to compress IPv6 headers, and however allows to use SHIC header compression to compress CoAP UDP headers. On the status of the draft, the document was adopted in January, and today I'm presenting version 02, which includes several additions, several updates, and by the way, one co-author, Flavian Mulek, who had joined in 01, has now become a contributor due to some company changes. So this is the table of contents for the draft. While there are several updates, rather minor updates throughout the whole document, the main ones, the main updates are the ones highlighted here. So also these are the ones we're going to focus on today, along with a couple of questions I would like to make to the working group. So first we have the main technical updates in section folder 3, which is on the pointer-based route over frame format. And the main new additions are Appendix A on header compression examples and Appendix B, which provides an analysis of route over multi-hop approaches that are defined in this document. So starting with the technical updates, they are again in the pointer-based route over frame format, which is the one illustrated on the slide. In the previous version of the draft, the leftmost field was the SHIC dispatch. However, here we are requesting a second 6LoWPAN dispatch type, a second bit pattern, for what we call here the SHIC pointer dispatch, which is a field that allows to indicate that what comes next is actually the SHIC pointer. So the point is that in the previous version of the draft, the first bit of the SHIC pointer indicated whether there was a pointer actually or not. So by doing this, now if there is a SHIC dispatch, after that, any bit can be used. It could be a 0 or a 1. So this does not limit the scope, the amount of rule IDs that can be defined after the SHIC dispatch. Also, remember that the SHIC pointer is a field that will allow to tell a receiver of a SHIC compress packet the location and the size of the compression residue of the IPv6 destination address, so that this receiver, if it knows the corresponding prefix, can reconstruct the original IPv6 destination address and, for example, route the packet to the destination even if it doesn't have the SHIC context, the rules. So there is an update in the SHIC pointer format itself. The first one on top of the slide is the older one, which started with the P bit that I was mentioning before, which indicated whether the pointer was actually present or not. However, what we are doing in 02 is equivalent to moving this P bit to the last bit of the dispatch. So now the new SHIC pointer format is byte aligned. The first bit is a reserved bit. Perhaps it could be useful for future functionality. And also the address length has a size of 7 bits. So it allows to represent a full 128-bit IPv6 destination address if needed. Then regarding Appendix A, this appendix provides header compression examples. There are 5 sections here, and actually only 3 of them are currently with actual content. These are A1, single hop or straightforward route over, which provides an example based on an IPv6 UDP uplink packet. Then there's A3, which provides an example on the pointer-based route over approach, also on the basis of the same IPv6 UDP uplink packet, and A5, which illustrates this transition protocol stack, and it uses an IPv6 UDP co-op uplink packet. So as an example, to illustrate what kind of content we have here in this section about examples, and sorry for the redundancy, this is the kind of content that we have, for example, in A1, the header compression for the single hop or straightforward route over. On top of the slide, you can see an uncompressed IPv6 UDP packet, which compresses 55 bytes, including a 7-byte payload. This is the input of the SHIC compressor, which in this example uses rule ID 0x20. And on the right, inside of this red rectangle, is the rule that corresponds to rule ID 0x20. And as a result, we have the SHIC compressed packet at the bottom of the slide, which has a size of 17 bytes, including the 7-byte payload, and also including the SHIC dispatch, which is prepended to that. Then, regarding Appendix B, the point here is that, as you may have seen, in this document, there are currently 3 different route over approaches for multi-hop communication. And on occasion, there has been a question on whether perhaps we might want to reduce the number of such approaches. So we aim to clarify things and try to guide a bit in this kind of question and analysis. Appendix B provides some analysis of pros and cons and features of the three currently defined multi-hop route over approaches. The first one is the straightforward route over approach. This is the one that incurs the lowest header overhead. It's only 1 byte. However, it pays the penalty of all nodes, including any intermediate nodes, having to store all the rules in use for compression in the whole network. So this would rather be suitable for small static networks where perhaps there's not many communication flows. Then the second approach is the tunnel ripple-based route over approach. This one was designed to avoid the issues of the first one, so that in this case, a node only stores the rules for the communication it is involved in as an endpoint. So this reduces the memory requirements and the impact of any SHIC context updates, if any. So it is more scalable with network size. However, there's a little bit of a penalty in terms of increased header overhead, which comprises two parts, 2 bytes plus a variable part. The variable part is at least 6 bytes for uplink transmission, and it could be more than that, for example, 12, 16 bytes or others for the downlink due to, among others, the source routing header. In this case, well, this approach requires ripple non-storing mode, which may be in place anyway in some scenarios, and also for internet communication, the idea is that it will require traversing the root node, which might not always be necessarily optimal. Finally, the third approach is the pointer-based route over approach. This one also shares the nice property with the second approach that a node only stores the rule for the communication it is involved in as an endpoint. So this also reduces memory requirements, impact of any context updates, if any, and this makes the solution scalable with network size. However, again, the penalty is in terms of somewhat increased header overhead, which comprises two parts, 3 bytes plus a variable part. In this case, the variable part is the IPv6 destination address compression residue, which could be 0 bytes in very special cases. For example, when there's a full address known beforehand, it might be possible to signal that with the pointer. Then it could be from somewhat somewhere between 2 to 8 bytes in intranetwork communication if the prefix is known, and the variability might depend on how the interface identifier of the addresses is built in the network. And then it could be a full address, 16 bytes in communications with external nodes, especially if there are several possible destination prefixes. So another feature of this approach is that it does not require ripple, and in consequence, for inter-network communication, it is not constrained to traversing a root node. However, it might be constrained to other features of the routing solution used, if not ripple. So trying to summarize a little bit, the best fit appears to be for small networks, the straightforward approach. For larger networks, when we need scalability, then we may prefer tunneled ripple-based approach for communication with especially several external networks, if that kind of communication is dominant, and the pointer-based approach if intra-network communication or special cases of external communication are actually dominant. So after this, we would go back to the question that I made, or we made on the mailing list some days ago, which is, okay, there are the 3 existing multi-hop route over approaches. Should we keep them? Should we try to reduce the number of such approaches? In the author's opinion, we should try to enable all of them, since they are quite complementary, actually. And then the most suitable one can be chosen for each particular deployment. We've also received some feedback on the list and off the list as well. However, well, we'd like to take the opportunity to know which would be the thoughts of the working group on this topic.
Hello, Carles. Yorgos Papadopoulos from EM Atlantic. As I said on my emails sent to you and to Anna, I think we should keep all 3 of them.
Thank you very much. Pascal?
Carles, this is Pascal Tuber, Cisco. I believe that as long as you give a clear applicability statement for each method, yes, I agree with Yorgos that having the three of them, if they really apply to different use cases, and it's very clear that they do, then it's worthwhile having them.
Thank you. Okay, any other comment? Okay, then we can move to the other question, which was also posted on the mailing list, because on occasion, we've received some comment that perhaps this document, which has been written so far as a 15.4 specific document, perhaps should be a generic document. So currently it is 15.4 specific. As the authors, we believe that, well, this allows a well-defined scope, and we believe that then it is more straightforward to create and to write the specification. Then perhaps there are some observations or comments here. So if we finally continue with the current scope, a 15.4 specific document may be the basis for other similar documents that might be written after that on other similar technologies, actually following some approach relatively similar to what happened with the original 6LoWPAN work, which targeted mostly 15.4 networks as the underlying L2, and then subsequently 6LoW has been producing other technology-specific documents based on that. However, if the working group decides to follow the generic approach, then in addition to the generic-based document, there would need to be one technology-specific document for each technology of interest. So which would be your thoughts? Laurent?
Yeah, just for your Laurent Toutain for IMT Atlantic, just for your information, there is something really new that appears during the hackathon this weekend, is that with Pascal, we try to design a chic header that can be also compressed, so that can be very, very compact. And maybe one idea is maybe to put the pointer on this chic header. So we have to see, because it's really, really new, but that can be a way to generalize things, because we were working on IPsec, and that's why this idea come from. So maybe there is link between 6LoW and chic over IP.
Okay, thank you. Thanks a lot.
Carles, may I?
Yeah, sure.
I want to complement what Laurent just said. So we, as IP1 chair now, we have a work group item actually to deliver a chic header. And your document refers to this chic header that we are committed to provide. And yes, we are making progress, and we'll be making a lot of progress in the LP1 sessions shared with Sheikh on the description of that header. The idea is effectively, as Laurent said, that we describe it as a real IPv6 header with all the formats, options, etc. And then we expect that it never flies uncompressed, right? It will always be compressed, and there will be a default rule set to decompress it, but that allows to elide all the fields in the header that you do not need. So that gives you a lot of freedom to have in the chic header some fields that you care about. And so the feedback that we'll need from you as part of this document is what data would you really like to see, like this offset, right, in the chic header, so we can describe it in our specification. And then the technologies that don't use it, they will just compress it to 0. And so that's how it's very cool to use chic to compress that header. So that's one thing. Second thing, that was your main question about how generic we want this document to be. At the end of the chic working group, when we wrap it up, we want to have described the various use cases that we can have. 15.4 effectively is a use case in a wider mesh type of network. So we expect to have the wider documented somewhere. And how it's documented will be probably part in the architecture. What is very, very generic, like presenting, you can do a tunnel between A and B, or you can do a compression, decompression at every hop. there needs to be some text about that in the architecture. So in the end, that we'll have to extract it from your doc, and you will have to point on the architecture document for this sort of thing.
Okay, thank you very much.
I have a question for Pascal. Can I get you on the record saying that there's no conflict between this document and work that Sheikh is doing? Sheikh? Yeah, so we're all fine. Good. Thank you.
We are working hand in hand. I mean, this is different working groups, but I mean, we work quite closely.
Okay, so I guess there's no other comments. Yeah, Michael said on the chat, do a document for 15.4 if that's what you want to deploy, and allows others to do theirs, because otherwise you'll never finish. Okay, thank you for the comment, Michael. So yeah, that was my last slide. So any comment or question? Yeah, there's a +1 from Karsten. Okay, so thank you. So then the next presentation will be by Luigi.
I'm requesting to share the slide deck. I have it.
Is it working, or should we browse the slides for you?
Carlos, I think you should give me permission. You should have something on the screen on the left side.
You should be able to accept it, Carlos, because
I have it.
Okay.
Yeah. Oh, okay.
Here we go. Share. Okay. So everybody should see my slide now. As for the agenda, this is an update on the PASA document. Between 116 and today, actually, we did 2 revisions of the document. I will go through the changes that we did. Okay, document by document, just to be to better explain the different changes in a certain way. Okay, so as I said, the first revision we submitted in May. The main changes were about security consideration. This was one rightful request we received during the adoption call of the document. So yeah, we started with that one as a main work. For revision 02, actually, we tried, the main focus was to try to solving the conflict that we have on the bits in the ERO option. I will explain everything and try to visually show the conflict and the solution that we did find. And my phone goes over and over again. Okay, so for 01, the main updates was some restructure of the PASA address allocation section in order to have a more logical flow. We updated the format of the ERO option in a first time on this revision, and as I said, we added a real security consideration section. And before we had just basically a reference to a few RFCs that should be applied. And we actually added also a privacy consideration section, okay? And as usual, some text refinement that we do at every revision. So for what is the address allocation, you see the old structure and the new structure. We try to concentrate in one place everything that concerns allocation. And we also introduced some renaming. So because we we basically, in this document, we propose one single allocation function, which is this three based allocation function. We decide to put this clearly in the name. So it's not AF anymore, but it's TAF, so tree allocation function, okay? And we group it all the text, as I said. And obviously, if we change this small acronym, let's say we have to rewrite a little bit here and there the document. In this section, we also put the text that discusses what happens if we have different allocation function. Because if we have different allocation function, then the way you rebuild the full IPv6 address, starting from what you have in your allocation function, may differ. Okay, so there is text about this consideration. And as I said, the alternative allocation function. The main meat is about security. Okay, we did write a more extensive section. I mean, it's not huge anyway, but since we are using a lot of machinery, obviously there is a lot of references to existing RFC whose security consideration apply here as well, okay, and a recommendation as well, in particular RFC 8505, okay. One thing that is specific to PASA is the fact that depending on the allocation function that you use, you may have a limited number of available addresses. What can happen is if there is a malicious node, you can leverage on this knowledge, impersonating different nodes and continuously asking for a new IP address and basically exhausting the number of addresses that are available. Okay, yeah, this is a feasible attack. I mean, the only way around is be careful who is in your network. I mean, otherwise this is a risk, which is now documented. The other point was in the privacy considerations. The first consideration is if you build the address algorithmically, this may reveal topology information, or let's say you can reverse engineer the algorithm and looking at the address, you can understand things about the topology. This is especially true in the tree allocation function, okay? Because in the way we build the addresses, you know how the topology. And you have an example here in this slide. If you have an address that terminates with 2B, okay? So the first part obviously is the prefix. We don't care about it, but 2B is the binary for 101011, okay? Now, with the tree allocation function, the trailing 1 bit indicates this is a host, okay? And then it means that the parent address has an address 1010, okay? And the trailing 0 indicates that is a router, so a node in the middle. The other 0 in the same address tells you who is the parent of this node, which is actually simply 10, which is then directly connected to the root, because in this allocation function, the root has address 1, the compressed address, obviously, okay? So by scanning the network, you can understand that there is the root 1, a first router 10, a second router 1010, and then a 6LO node, a host with address 101011, okay? So this is a privacy concern. Now, it depends on the deployment, whether or not this is an issue to you. If it's not, nothing to worry about is if it is a private deployment, for example. If not, then you certainly need to deploy something in order to hide your topology. One possibility is to use something like NAT66, okay? Eric is not in agreement.
Don't.
It's not a must.
This is not a can of worms you want to open. There are other recommendations you can put there.
We better not open the jar. So let's move forward. The format of the ARO option, we worked on that as well. So what you see here is actually what is proposed in the 6LO prefix registration document, which actually should be discussed right after me. I have 2 slots, but then there is Pascal. So the point is that there are 2 fields. The P field that basically is a 2-bit field that tells you what kind of address we are dealing with. Okay, and the F field is about whether or not we are requesting to forward the packets, or the router forwards the packet on our behalf. Okay, this is not in the PASA document. Okay, in the PASA document, what we had in the 00 version is this. We used 2 bits, okay, one to indicate the PASA functionality, and the other to indicate whether or not the node is a host or a router. Okay, so that the allocation is different. Okay, now as you see here, there is a conflict in the bits. Okay, we use the same what was previously reserved bits flag. Okay, now in 01, what we did is very, very simple. We shift the 2 bits forward, okay, which does not resolve completely the conflict. Okay, we have still bit overlap, 1 bit overlapping, the F bit and what is the H bit. Okay, but this is what we actually did as a quick solution in 01, but it's not a complete solution, obviously. Okay. Yeah. And Pascal did the comments. We have to solve this conflict, and we decided to target this working item in 02. So what you see here is the difference between 01 and 02. So we added a new section as a definition of terms because previously was diluted in another section. We again added some renaming to better highlight that everything is about addresses and only about addresses, nothing more. We did some restructuring, so we changed it again, the structure, so to group all the operation in the first part of the document, and then all the formats of the different options and messages in the second part. Okay, and because of the changes that we introduced in order to solve the conflict, now we have a new way to signal the fact that a node supports the PASA specification. Okay, I will show you into details. Yeah. Okay. Let me go quickly. So we have the definition of then. This is just text that has moved in a specific section, nothing more, and then we adjusted the rest of the section. As I said, a smaller restructure so that we have all the operation at the beginning and all the format afterwards. Now, first thing is how to signal the PASA capability. Instead of using the P bit in the ERO option, we can actually use the 6LO capability indication option. Okay, so there are a few bits already allocated. We propose to use another one. So there are already 2 bits that are used to indicate whether or not the node is a router and whether or not it's a border router. We add another address field bit to indicate whether or not we support PASA. The P bit is already taken. We put A for address. Okay. If A is set, it means that it supports algorithmically assigned addresses. And then you look at the B bit, L bit to decide whether this is a PASA route, if it is a border router, is it is simply a router, this is the L bit. And if both bits are 0, means simply is a node, so a host, a leaf in a certain way. Okay. So what it means is that the H bit is not needed anymore actually in the error message. Okay, because we have everything we need here. which means that only in the error message, what we need is just one bit to signal I'm supporting PASA and I'm requesting a message, an address, so that when we register a link local address, we can also ask for another address based on the PASA specification. Okay. And the main procedures remain the same as in the previous version. We just move it around a little bit. So this is the update on the first document. We are not finished. We have multicast considerations to do. It would be nice to add also some text about DAD, so duplicate address detection, because with some allocation function, the address is unique by construction, like is the case in the tree topology. So any comments, further comments on this one? Otherwise, I go through the second slot.
You have 5 minutes.
Okay, let me shift it.
Bit and I'll give you that time from mine.
No. Let me. Carles, can you approve again the sharing the slides? Okay, thank you. Okay. The motivation of this document is very simple. Yes, we have one bit still in the error, but what is bothering us is, in order to request the allocation of an address, we actually need to register an address. Okay, because this is what ERO option was made for, register addresses. So it's not so logical. So we decided to propose to have a new option. So usually when you request an address, you first make a generic request. I want an address. You have an offer from one or several routers, and then you have to confirm. I want this one, and the router to say, okay, this is yours. Now, the second part, the confirmation, we can do it simply using existing machinery, which is the ERO option, okay? I register the address that I received, okay? Which makes totally sense. The first part is where we need a new option, okay? In order to explicitly request the allocation. And that is why we proposed the GAU. Now the title is mistyped, but is the generic address allocation option. The structure is very similar to ERO because it is a sequence. You use first this one and then the other one. So it would be good to simplify the usage of both one after the other. So let me skip a few things. Let's say that the opaque, all the fields that you see here are basically the same like in ERO. The differences is here. We have a field to indicate the address allocation function that has been used. Lifetime is the same, and then we append the address. The one thing that is a little bit peculiar is the status prefix length, because it works like that. If there is an error, there is no address that is returned in the corresponding neighbor advertisement. In this case, the length remains 1. And this field gives you the error code like in 8505, okay? Instead, if there is an address that is appended to this message, the length becomes 3, which means that actually this field gives you the actual prefix length of the address that is appended to this message, the option, sorry. Okay, that's the only small tweak. Which means that basically what we have now is a generic procedure that when a node comes up, he can send a neighbor solicitation with the GAU option, receive the neighbor advertisement with telling, I propose you this address, and then you use existing machinery without any change in order to register the address of your choice, okay? Which is in line with the other specification about prefix and multicast registration. And yeah, you can still signal this capability in the capability indication option. If we go with this solution, PASA doesn't meet this PIT anymore, so we can use it in this document as a real generic solution. And that's it. Any question or to the mailing list?
I have.
Yes.
Yes, I really like Pascal Tuber here. I really like the idea of defining a different option for this, and I just don't believe that you need to keep aligned to ERO. ERO will change anyway, so being aligned at one point of time is not necessarily an objective. It's just it seems to be more trouble to you than help. Because, for instance, the length of that you give back for this address, you could put it in what is the opaque field today, just as an example.
But then what do you do if you use the opaque in the ERO?
Because if you don't say that this option maps to the ERO, then you can do whatever you want on your side, and we can do whatever we want on ours.
But I see the opaque, like if you use it as a identification for a different routing tables, it must be coherent between the two options. You see, that is why we put that field. Now, but this is a rough idea, and I think we can refine it by discussion.
Globally, I encourage the idea. I mean, I'm all for it.
I mean, it's the rough idea, so we can discuss.
Well, yeah. Point being that when you register it, you'll be able to say in which topology you want to register it. So that's at the second flow, which is an ERO. On the first flow, you're just asking for an address, unless you need to signal which topology you want it in.
I see your point. Yeah. But let's continue the discussion later, so that give that. Any more question? No? Okay, thank you.
Okay, thank you, Luigi, for the time management. So the next set of two presentations will be given by Pascal. The first one is on the IPv6 prefix registration.
So, Carlos, can you move the slides for me, please?
Yes.
Okay, so one little change since Luigi built his slide is that the 6LO prefix registration document has been adopted as a workgroup document. So now it's a draft IETF. Next slide, please. Okay, so there is a long story that we've built in this working group about the capability to register addresses to the router. So you can do a route over protocol that will basically expose the route to that address inside the subnet, meaning that the subnet now can be decoupled from the broadcast domain, which was our small radios. So it started with 6775, which was updated by 8505. 8505 updates but does not reply 6775, so you really need the two of them. And so that gave us basically the capability to register one address. Then we had 8928, which allowed us, and that we'll come back to that, but it allows us to guarantee the ownership of the registration if the requester which wants to register this address later appears somewhere else. There is a way to ensure cryptographically that is the actual owner of that address. So that avoids all the savvy issues of injecting addresses or getting traffic for an address that you do not own. Then we worked on, we said, hey, we can register global unicast addresses, blah, 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 that's very nice. But why don't we do the same thing for multicast? Effectively, for instance, the Ripple protocol can carry multicast and unicast addresses. So why not use the same registration over ND to replace kind of MLD, right? Because MLD is just like broadcasting ND. It goes on the wrong direction. It's the router polling the devices about which multicast addresses they want to listen to. But the devices are sleeping, meaning that they won't hear the report. And that was effectively a big problem for the YSAN people. They wanted something as simple as 8505, also for multicast, and they wanted to get rid of MLD altogether. So we basically created that draft for them, which is let's, instead of registering a unicast address, let's register a multicast address. And then we realized that, okay, anycast falls in the same bucket, so let's also register anycast addresses. And effectively, there is the counterpart for that in REPL as well in this document. So this became a workgroup document, and now it's in the workgroup last call / the beginning of IESG type of phase. And the one thing that was missing is the capability to register a prefix. So the idea here is that you have, maybe next slide, please. I have a drawing for that, I guess. Yeah, okay. So the idea is we have an entity, and there can be many forms of entities that allow this device, let's call it a router because it has a prefix, but there was this morning at 6 Ups a discussion whether it's a host, a prefix, or both. But let's say it's a router. We've got this some entity that delegates somehow a prefix to that router. And the different ways could be, yes, the usual DHCPPD, that's one. You could autoconf a ULA prefix by doing some random computation, that's two. Or there could be something like an EPAM, in a cloud environment that would basically say, hey, you've got this prefix. Either way, we've got the problem that between this entity and the router which gets the prefix, well, we have an understanding that this router can use this prefix, but all the routers, the other routers in this network, they're completely unaware at this point that the router just got the prefix, okay? So there is no route anywhere. And what we do with this registration is we provide a mechanism that is agnostic to, on the one hand, the entity that provided this prefix, so even autoconf of a ULA, and on the other hand, what routing protocol, like a REPL or anything, happens inside the network, like what we call an SGP in the 6-man documentation. So by having basically the same ERO option used for registering a prefix, we decouple the allocation of the prefix and the injection in the routing protocol. We use the same protocol and in the middle to connect one with the other. And if you look at it for most solutions we have, which do some prefix delegation, we are missing that link. Whether you talk about 6/64 to the host, or you're looking at SNAC, etc., there is always this little missing link between the moment where the prefix is allocated and the moment where the routers are aware of that prefix. And we want two things for that. We want to ensure that there is a unique allocation if the prefix is uniquely owned by a router, and we want to ensure that it's truly the owner, like we are not injecting something that we don't own. And if you look at it with 8505, 8928, we already have that sort of capability for addresses, so it's mostly a matter of passing a prefix with it, a prefix line. Okay, next slide, please. So why are we registering this prefix? Well, one thing that could happen is that the prefix that we register is injecting in the subnet routing protocol, like REPL, the routing protocol that sustained the multi-link subnet. Or it could be that there's just a need for, on the same broadcast domain, for other devices which belong to other subnets in the same shared link to be able to ping a device in this subnet. You don't necessarily want to have to tell all the hosts on this shared link, like SNAC, that your prefix is available. You just need to tell the routers. If you tell the routers, then the host will just send the packets to their default gateway. And guess what? The default gateway, thanks to this registration, is aware that you own that particular prefix. So that allows basically to close the loop and install any sort of gateway in your network that will just own its prefix and some devices, and it will get the traffic. So there is a signal in 8505, which is the R bit, that allows the host that registers his address to say, please inject that in the SGP. It may decide to use those routers to inject in the SGP, and those other routers not to. Just they are aware I'm here, but they won't be injecting it in the protocol. We can do the exact same thing for prefixes. Now, there is one thing that Luigi has alluded to earlier, which created an initial conflict between the specs, is the use of one particular bit in the bit field, which is the F bit. So this is recent. And really, we have to wonder if we want to keep it. I just throw it in that text so that we can have this discussion. But think about what it is exactly. So the normal use case of a prefix registration is like snack. I'm a router. I own this prefix, and I just want the other routers to give me the traffic, or eventually to inject it in the SGP, so I'm receiving the traffic from farther away. But now there is another use case which reverses that picture. The prefix now, I own it, but it's not on this shared link like snack, it's on the other end. It could be an ISP prefix if it's a provider-dependent prefix, like a multi-homing type of situation. Meaning what I want to tell to the other routers on that link is not to give me the traffic for which this prefix is the destination. I want them to give me the traffic for which this prefix is the source. So the host sees multiple prefixes on its link, including mine, right? And it may pick an address from that prefix, and it will pick any router and pass the traffic to that router. So the traffic that is sourced in my prefix might reach another router. And what I want to tell that other router is, oh, look at the source. And if the source is my prefix, pass it to me. All right? So it still registers a prefix, but it's to tell the other routers, give me the traffic that is sourced at this address, not the traffic which destination is on this address. I'm not a stub. I'm actually a service provider. And so I don't know if it fits in the same document. It's really the same registration. It's just one bit to pass. And the service on the router, on the other hand, that accepts this registration is to be able to look at the source of the packet as opposed to the destination. And if the source is in my prefix, give it to me. It's a new function. It's something which is not exactly what we're used to be doing. So I insist on that because we might want to take it away from this document. Maybe it creates complexity. We want to have this discussion. Otherwise, it's kind of a useful service. Because if I have this phone, right, I have my phone, which has a service provider prefix, and I want to connect it to my home network. And basically, if my ISP wired connection dies, I just want my whole network to be able to use the prefix from my phone. Well, if this feature is available, if my phone basically registers to the routers in my home the prefix that my service provider gave me on that phone, and the routers know now that every packet sourced at that must be given to me so I can send it on my phone. That kind of solves a useful situation. I mean, it happens to me at home that my ISP network breaks. And I would like to be able to just plug my phone and get connectivity back. So that's what this flag is about. And yes, I would like to discuss on the mailing list if we want it or not. Question? Yeah, go ahead.
Luigi, so first simple question is, if you take it out from this document, the plan is to put it in another document, right?
No idea. I mean, for now, I'm just injecting an idea to the thought process of the IETF. And I have no plan at all. I just wanted to write it somewhere someday. So it just makes very little additional text in this document if it's on this one. If it has to be on another document, then we have to start progress, etc. the document. But if we decide to, as a group, or what, to make it another spec, we could.
So my personal opinion is this is it's just one bit, but it's a very peculiar way of how you use the registration.
You register for the source, not for the destination.
So in putting this in one single document, I wonder if generate complexity and confusion in a certain way.
That's my question to the group.
And so coming to the example that you made about your phone, that you want to register, say, all the traffic with this, so you send it to me, please. Okay, so there is the issue, you have to prove that you own the prefix. But aside from that,
that's another part of the document.
Aside from that, I mean, maybe this kind of use cases might be documented in a separate document and then put the bit. I don't know. It's just, I wonder really the complex.
I understand your question. I have the same. That's why I'm putting it on the public place. And I guess let's talk on the mailing list because, yes, our time is kind of constrained now. But that's basically, I think that because otherwise it's kind of a basic method. I mean, the idea is to use exactly what we do for addresses, that is first come, first serve. Now, if there is an external entity that delivered the prefix, then we tie that to 8928 so that there is a key pair associated to the ownership. So that key pair must be given to the host at the same, well, the router at the same time as the prefix. So now he has the ownership. The way it happens has to be defined protocol by protocol. For instance, with DHCP, the node could provide this public key to the DHCP server, and the DHCP server would write somewhere that effectively that public key is associated with the address that it will give back, that goes, and then the 8928 process works just for a prefix. So that's one way of doing it, just as an example. So we can secure effectively, at least in some cases when we have visibility on the IPAM of the day, we can secure the ownership, we can trust it. And that avoids discussion with whichever IPAM that is, or DHCP, we made that abstract, which is the cool thing. Next slide. I have to move to the other steps. So yeah, one point is you also mentioned the P field, Luigi. So the P field is 2 bits, and we made it a field as opposed to a bit because that allows us to have more value than just 1 bit on, 1 bit on. We had 0 was unicast, 1 was anycast, 2 was multicast. Well, the bit for 1 was anycast, the bit for 2 was multicast, but they are kind of mutually exclusive. So let's make it a P field of 3 bits. And now we can indicate that we register a prefix as well. That's what the P field is all about. Next slide. Okay, and basically this is the illustration of the P set being used for registering a prefix, and the R bit being set to say, hey, you inject it, or no, you don't inject it. So you can select which of the routers you register to will inject the prefix. Next slide. And what becomes of that? Okay, so for one thing, we can prove the ownership, but that's not that. That is about uniqueness. And for addresses, it's just a direct match. Does this address already exist in my database? For prefixes, it's more of an overlap game. If for instance, there is this /64, which is available for the whole building, and some device wants a /96 out of it for doing, I don't know, IPv4, what it can do is generate a random number for 32 bits and register the /96. And effectively, the goal for the routers will be to look at this routing table and say, is this prefix already taken or is it available? And by taken, we mean is there some overlap with a prefix that is already taken and that's reserved. So that will be more of a overlap game as a game of exact match. But otherwise, it's going to be first come, first serve, and then, you know, IPAM validation. Next slide. Which means you can auto-allocate a prefix, by the way. You can auto-conf a prefix. That's part of the game. So this is the security of it. It's the same 8929. Pass, please. Next slide. 8928, I'm sorry. And this is just an example that I was giving effectively where you've got an EPAM and you effectively have a cloud and you want to use this in that situation. So you want to encapsulate IPv4 in a /96 for that particular tenant. And basically what happens is you register the prefix for the tenant and then you encapsulate the v4 addresses into it. And that's pretty much it for that. The next slide, please. I think we're done, right? Yes, there are a lot of could-dos. Yeah, let's move to the other slides. So there is the question of the F-bit. It's a different procedure. It's almost the same. You register the prefix to all the routers, but what you're doing is you're telling them, instead of looking at the destination and passing me the traffic, which means injecting me in your routing table, here you have to put me in a source table. And if the source matches my prefix, then you give the traffic to me. And since they're on the same link, then it's just, you know, link local. So you just pass the traffic to the MAC of my link local. So it's routing, but not, it avoids routing, source destination routing in the whole subnet. The packet will reach any router, but that router will be one hop away from mine. So there will be always one last hop to get the packet from any router that the device has picked to the router that effectively can send the packet over the internet. And that's pretty much it. So yes, I'm happy to take questions on the mailing list. Yes, you have a question? Okay, so this is more for your information. So it is the architecture and framework for IPv6 over NBMA. Next slide, please. So you're aware of this document. I've presented it in this group several times. Initially, it was really targeted at the kind of networks that 6LO works on. And now we want to generalize it, not to all network. I mean, I must have been unclear on that because I got the point by Lorenzo this morning. The idea is not to replace Slack. The idea is to say there are networks where Slack is perfectly okay, and that's pretty much when the broadcast domain is a good match for the subnet. And there are networks where it's not okay. And our radios were the first types of networks for which it was not okay. And it was very clear for the 6LO pan-working group very early in the design. And now we realize that it's not true only for radio, but for instance, EVPN networks, just to give you one example. Cloud networks, I mean, more generally, you want to know which address is where. You've got some IPAM which gives you an address. You want the overlay to know exactly on which underlay top of rack this address is located. And for that, you need an absolute knowledge of which address is where. And it's not by snooping Slack that you can get this. So we finally got the document adopted at 6-man, but Bob here asked the authors to turn the scope a little bit more fit to the 6-man working group, which is basically to focus on the architecture piece of what we are doing as opposed to a prime statement. So it's still a prime statement. Next slide, please. But we will focus on the architecture. So the prime statement initially was, what's the prime with wireless? And as you see now, we have basically listed a lot of issues in a number of cases, and one of them is sustainability, believe me or not. When you have a broadcast domain that spans over continents, broadcasting every single DAD over the whole network is not so good for the planet, right? So we have all sorts of reasons why we want to separate the broadcast domains and still have the subnets where we want to place them. So that's pretty much what this architecture does, splitting the broadcast domain, the layer 2 constructs in general, from what we do at layer 3. So we have to, next slide, please. We have to provide an architecture in which the terms now are very, very specific. We don't define a subnet as being a direct mapping to what layer 2 has. We define a subnet as being what you want it to be, by the way. But you have constraint of interconnection, etc. And then it's mostly a definition in terms of administrative decision and mapping the FF0345 onto what you're designing. So you know this RFC, I forgot the number by Ralph Drums, where he speaks about the rim local, etc. So we define a link, which is kind of a limited scope. It could be a point-to-point. And then you've got all the FF above, which allows you to reach farther into domains, right? And some of them are purely administrative. I think FF05 is purely administrative. But basically, we have to provide mappings on what we see as a subnet, what are the constraints of a subnet, and how you can reach everybody in the subnet if you want to. And then the core function in that architecture is ND on the first hop as the UNI, as the user to network interface, like the host to router interface, ND with the arrow, and then routing between the routers exposing host addresses, and small prefixes if we add the prefix registration that we just saw. So we're still inside the subnet. We have /128, we have /96s or whatever, and they're all injected in this SGP so that you can reach any of them. That allows you, routing allows you to separate the broadcast domain and even separate the technologies. I remember this IEEE 802 meeting where the guys wanted to bridge 15.4 on Wi-Fi or 15.4 on Ethernet. And guess what? 15.4 has 8-byte MAC addresses. And we ended up finally managing to convince them that if you want to go from a 6-byte MAC to an 8-byte MAC, it's routing. You have to go all the way to layer 3 and back. So So it was a very hard discussion. We made it. But now you realize that you can route inside a subnet. So if their real need was to have the same /64, with this specification, it's perfectly doable. It's just that you don't bridge. You go all the way to L3 because you're really changing your MAC frames. And then we are providing a real specification of the abstraction. Next slide, please. So first piece was the prime. Second piece is the architecture. Third piece is the framework, which is more the piece that this group is actually guilty of. Because the framework that we propose to actually implement the architecture is based on the work, largely on the work that happened at 6LoWPAN and 6Lo. So it's how we use all those RFCs that I've listed earlier, IETF117-6Lo-20230725-2000, and prefix registration, multicast registration, etc., SGP, to build your distributed subnet. And if you remember the term wind, well, one of the asks that we had on this mailing list, and it's Brian, I think, who provided the term, he said, hey, the key thing in this architecture is that the routing protocol is a subnet routing protocol. It's not the IGP that you run between subnets. It's a different kind of protocol. It's more of the MANE type, because it needs to be aware of mobility. And that protocol, we called it the subnet gateway protocol. Well, and EVPN is one such example, by the way. EVPN, BGP, and EVPN is a subnet gateway protocol. Well, we are just providing like an architectural umbrella for things like EVPN. Well, we are basically leveraging all the work that 6LoWPAN has been doing to build this framework. And well, that's a nice outcome of the work that we've done here, basically. And we inject anycast, multicast, prefixes, etc. It all works. Next slide, please. And so the last piece is the applicability statement. So it still builds on the Wind one. So now that the core piece, so I was saying, is the subnet gateway protocol, Wind is being renamed into SND. So if you see SND, that's because it's no more wireless. It's really this separation between the layer 3 abstractions and the layer 2 abstraction, which allows us, which requires actually to use an SGP. Well, the example that we give in the applicability statement are all coming from the 6Lo wireless type of world. I understand that I have to provide some of them from the wild world. Example EVPN, but there are others. But for now, this applicability statement is the things we know. And for those who have not heard that, I mean, there are standards out there, in particular in the smart grid, which use all this stack, which use an SGP, that's repo, and which use IPv6 ND for registration. And there are millions of nodes. Literally, your electrical counters, I mean, they are all meters. They are all based on that. They all do 8505 and repo. It means that it's a proven solution, and there are millions of nodes out there which actually deploy it. And that's pretty much it for me. I may have a next slide, but yeah. So my ask, oh, can you come back? Yes, I have an ask. It's for everybody. It's for 6 months, also for you. It's hard to find in the IP, even IPv4 specification, a terminology for link and subnet gets, believe me or not, it's taken for granted. It's like everybody knows what it is. Why should I define it? And effectively, if you go down to the definition, the subnet is the broadcast domain, and my link is pretty much the same thing, by the way. It's when I put a packet on my interface, it goes on a link. And guess what? When MANE started looking at that, and then IoT, 6LoWPAN started looking at that, we had that problem that if my link is my radio, and I have a short-range radio, and I keep seeing different people, when do I do that? Right? If I build my MAC address for that link, my link local address based on my MAC, for instance, for that link, or on anything else, how and when do I do that? Because the people who can hear me at any point of time are very different from the people who can hear me at a later time. So if there is a collision, there's no way to detect it. I can't do a DAD today that will be valid forever. So the MANE people and the 6LoWPAN people, us, we decided that a link is always a pair of nodes. And that's the way 545 is written. You know, that between two nodes for a link local, that for a link local, it's just I talk to you, and if we agree that basically in the scope of our interface, each other's interface, that address does not exist, then it's unique because that's the scope for uniqueness that we desire is I'm talking to you. If I'm talking about the same interface for somebody with somebody else, I can use a different link local, or I can use the same value of the link local, although it's a different link, to talk to him, as long as it's not a collision for him either, right? But the link is one. It's in this architecture, most of the time, it's point-to-point. It doesn't have to be. We define the link as a more general thing. Ethernet is still in there. But we also define in our framework that we use point-to-point. And then subnet now is this administrative domain. We end up with a document which is almost 60 pages long. I also got on the mailing list a comment by Lorenzo that it's a bit big. And now it's more for the AD, right? I mean, is it something that we need to split? Is it easier for the ASG to digest it as one 60-page document or 4 documents? Or,
it's hard to tell. Sometimes documents come together in group, separate documents come together, and ESG says merge them. And sometimes a document comes and it says split. It was and when it was previously several separate documents, it's hard to know.
So if the ISG is kind of the final word for this, is there a way to kind of ask them in advance how they would like to see this document?
I can ask them as part of doing AD eval when this advances out of 6-man last call.
We need to wait last call. So at last call time, we can decide to split. That's what you're telling me.
Certainly, that's a point to do that. If you want me to do that beforehand, I can.
I just would like to end because we get the comment by Lorenzo, and now I need to address it.
Okay, I'll talk with Bob and yeah. Thanks.
But to my standpoint, I mean, still 60 pages. We could move the prime statement. One proposal I had to Chipang, it was to move the prime statement piece in that into his document at G6 Ops. But he said, now his document becomes too big if we do that.
Well, maybe we should, yeah, I guess it's worth, I guess we should have a look at this before I think too much more time passes because, I mean, there's many things in here that are very scary to me, right? It sounds like the Dave Thaler's IPv6 multi-link subnet document.
It's obsolete, yes. Is obsoleted by this because basically the main statement of this document is we are basing IPv6 on the same premise as before. And so everything he says after in the document. And yeah, we're saying, no, we actually break that. We undo that decision.
Yeah, that's enormous. And I think we should, and maybe even beyond the scope of 6-man.
Interesting.
So we'll have to think about what that means.
Yes.
Yeah.
All for it, and I completely agree with you. Now, Dave's document doesn't say MLTG is bad. It just says it's not in line with all the architecture decisions that we've made so far. That's
right.
Yeah,
this is like
the two exactly together.
Changing decades of assumptions.
Changing that basic assumption, yeah.
Yeah, so that's like not a thing to do lightly.
On the other hand, it's also taking, what's the English for that? But accepting the fact that it's already there. Because the 6LO networks are already there, EVPN networks are already there. So it's all already there. It's just that we have not accepted it.
No, but what you're doing is you're taking this thing that applies to maybe millions of nodes on factory floors or something, and you're saying that the billions of devices on the rest of the entire internet need to adapt because this other reality has changed.
I'm not saying that. That was Lorenzo's question this morning. I don't aim to replace Slack. This has an applicability.
Nothing to do with Slack. You're saying that this model over here is
one
exists.
Possible deployment model.
Therefore, we need to redo the entire interface between L2 and L3. You're redoing the multi-link subnet.
You don't have to deploy this everywhere, right? You can still keep your home gateway the way it is and not change, and the host will keep acting as they do.
That's the current state of affairs with 6LO versus sort of standard v6.
But even if my own gateway, does not support this, for instance, and does not place the bit in the 6CIO, and my Linux PC supports it, since my gateway does not support it, the Linux PC will operate as before. And then there is 8929, which allows to basically proxy from one side to the other, even if they're on the same link, by the way. So there is all the compatibility specs that are already there, like interop, same link, same physical wire, and the two of them coexisting. So it's not, you can't replace the internet like that. I mean, nobody is not
I hear that these things exist. Yeah, it's just it's an enormous thing to try to.
It is, yeah. The thing is, we don't try to do another V6 like a V8, which would never work. We are trying to change it from the inside and slowly but it's not a dual stack that you have to. It's just a new capability that you have in the protocol, which allows new deployments.
But you're
you can
redesigning the
put-
interface between L2 and L3.
We are redefining the mapping of L2 over L3, L3
Yeah,
over L2.
that's no small thing.
It's
So,
not. It's a new
yeah.
architecture document. And I understand that it might be too big for 6 men. Don't know. Because it's more than maintenance, I agree. We could decide to form a working group around this.
Yeah, you could try to have a BOF and charter working group for this. Yeah.
Okay, so we are a little bit behind schedule, but still, Michael had a comment maybe.
Is it working? Yeah. So I don't think we're redesigning the interface from L2 and L3. I think that L2 never actually announced any kind of an interface, and that we have essentially 30 years of L2 tricks where we try to continue to pretend it's a big yellow cable. And they've just pulled the wool over our eyes for 30 years. So say we're redesigning the interface is to assume that you knew what the interface was in the first place, and that was just wrong.
Maybe I should say redesigning the assumptions about the interface.
I would say just writing down the assumptions about the interface, because I don't think they're even written down anywhere. It's a big yellow cable. That's the only thing you can know
multi-link
about
options document captures many of
No,
those.
that wouldn't be our document. It would have to be the IEEE's document that tells us that it's something other than a big yellow cable.
The Dave document captures the fact that the IETF expectation that the subnet can be mapped on the broadcast domain. That's the one thing that it captures. And it says, yes, we did it on purpose. And probably the purpose was that V4 to V6 would be easy. Well, it proved not to be, even with that assumption. But now that assumption is killing us. It's like Michael said, we keep masking and masking and masking that the real world is not like that. And the cost is getting heavier and heavier and heavier.
Okay, thank you. So yeah, we should probably continue with the next slot. So thanks a lot, Pascal, and thanks everyone for the discussions. We'll definitely follow the discussion on the work. So the last presentation for today is on the transmission of IPv6 packets of a short-range optical wireless communications. It will be given by Young-Wan. So if you want, I can browse the slides for you.
Yeah, thank you. Can you move the slide for me? Yeah, thank you. I'm here again with another work item that actually, as soon as I finished that, the IPv6 over NFC. That is new one is the IPv6. Another one, the OWC. So it is defined that the IEEE 802.15.7. Actually, this is about the LED communication. Next slide, please. Actually, the name is short range optical wireless communication. This is short name is the OWC. Just use the intensity of modulation of the optical source, such as the LED, something like that. The OWC actually has the data communication with some lighting, and the OWC can be found everywhere, and the application in various domains. Just you can see that in the light in the room or so, and the signboard something, and street lights, and the vehicles, and traffic signs, signals, and displays, and the LED panel, something like that, and also the digital signage and the smartphone. You see that the LED. So LED device can be powered by the limited energy source, for example, that the battery and or the energy harvest, something like that, for the energy efficient services. So the three is like that. And the next slide, please. And the OWC actually defined that the IEEE 802.15.7 standard provided the 6 characteristics such as like that. The pointing icon that is the line of the site, just the communication is quite the directional. And the next slide. Considering on the IPv6 of OWC, just there's some 3 issues about that. The one is that the topology just OWC just supports the point peer-to-peer between the 2 devices, and the other some coordination or some kind of the AP something like that. The other OWC devices can receive the data in the like that, like a star, but IPv6 over OWC, maybe we can consider the more complicated topology like the mesh with that to a lot of device OWC devices with the P2P link something like that. And the other one is addressing just OWC using normally the 64-bit address, but they get the link between the 2 devices. They use also the 16-bit shoot address, something like that as well. And the MTU actually the OWC, there's the 3 physical layers. The phi. This one is the phi 1 is actually 1023 byte. This is the smaller size than the IPv6 MTU. So maybe this may be FAR, and the reassembly will be required. Then the other 2 is the bigger than the IPv6. There's no fragmentation like something like that. These 3 phi 1 to 3 actually depends on the devices. So some modulation of the encoding decoding from the device, transmit and receive the device, then they can use it. Maybe something like that the smartphone just use the camera LED, then the modulation quite slow. Maybe it will be slow. Use that the phi 1, and the other the one maybe like that. The device will be the fast one. And the feature is about that topology is with the 2 OWC link layer, and the feature layer. On the top of that, the adaptation layer IPv6 over OWC like that. The next slide, please. And this is technical issue about that IPv6 over OWC. Just we normally have such the similar issue, technical issue like that. Maybe I will bring the one by one the next the draft and the revise the proposed text, and then at this moment I can just introduce at glance. Next slide, please. And this is test bed. And the guy is the one of my author, the Chami Kim, and this is the kind of test bed. The 2 devices, then these 2, the TX and RX device to connect with the OWC, and the other is to use that the wired the network. Next slide, please. So just we got the 2 kind of results. One is ping responses like that. There's ping. The 2 devices get the packet from the ping, and the other one, the result is Wireshark capture about that the 6-band packet, something like that. Next slide, please. So at that one, just the testbed result you can find that the IEEE wireless communication letters about the IPv6 over OWC. Maybe we got the issue, that paper, the issue that like that. Maybe you can check it. Next slide, please. So the conclusion remarks. So I just bring here to the IP draft the IPv6 over OWC the first version, and then the LED actually is being widely used anywhere for lighting. Not just the typo lighting, the nature friend actually. The OWC the transmission by using LED based on the standardization IEEE 802.15.7. So consequently, IPv6 over OWC has shown promising results as one of the IPv6 over food technologies based on the testbed experimental outcomes, I think. Thank you.
Thank you very much. Yeah. So do we have questions in the room?
Thank you so much. I will bring that another issue with that on the next meeting. Thank you.
Yes, thanks a lot. So perhaps, perhaps as a co-author of the draft, the presentation today has been quite about the bigger picture, the applicability, and the technology. However, the draft itself contains already quite some technical content. So please, any feedback on that will be very much welcome.
Yeah. Thank you.
Okay, so any other comment or question? We are 1 minute behind schedule. So, okay, then this ends the session, the 6LO session today. So many thanks, everyone. We hope we can continue all these discussions on the list. And also, let's see everyone in the next session, in the next meeting in Prague.
Thank you, Carles. Thank you so much.
Thanks a lot. Thanks, Pascal, Eric, everyone. And then no one realized that we are late for this.